Okay, so we'll just go from here. It's starting to record now. So how would you attack this to make this be in the Cartesian coordinate form? Can you say that again, Aaron?
Would you put it in terms of theta? So, for example, the x equation, and then plug it into the y?
I mean, we could do that. Can you remember that one of the things, too, that you might want to remember is x is equal to r cosine theta and y is equal to r sine theta. So that's something that we could look at. That's a terrible theta. But one of the things that I would do is, because they're giving me it in terms of sine and cosine, couldn't I manipulate this in a way that makes my life easy by saying, hey, x squared plus y squared would be equal to sine squared 1/2 theta plus cosine squared 1/2 theta, right? Isn't that true? And what is sine squared theta? Who cares what theta is? Plus cosine squared theta. It's 1. So our equation ends up being x squared plus y squared is equal to 1. But we do have a restriction here, which is a little bit important, right? And the restriction ends up being in terms of our values for x and y. And the way to do that really is to look at, keep it in the coordinate system with degrees, right? In terms of thetas. And so when we go to graph this thing, since we're only going from negative pi to pi, doesn't that make sense that it would be this circle? Right?
Right.
But one of the important things is, since we're going from negative pi to pi, which way are we going? We're going clockwise, so it's going this way. So this matters, right? This matters to us. And so that helps us to figure out our values. So we see that it's going to go from negative 1 to 1 for x, and then from 0 to 1 for our y. Does that make sense?
Yes.
Okay. All right. So there is one problem. The second part was to graph it. So not too bad, right? But the crux is use information that you know and see if it's beneficial. So in this problem, because it was sine and cosine, it's very beneficial. If they had given us, secant and tangent, then you would try to manipulate with the formula that they have there, right? Or if not, what you would have to do is use something along these lines to be able to do it. Okay? But let's not forget about x is equal to r cosine and y is equal to r sine. All right? Okay, so the next problem says they want to find, so this was problem number 1. Here's problem number 2. They want us to find the equation, so they want us to find an equation of the tangent. So if they want us to find the equation of the tangent to the curve, what are we doing?
Slope.
That's right. And what does that mean to find the slope? That's right. I'm trying to write it down for you so you have the exact problem. Parameter. All right, and here's what they give us. They give us x is equal to 3 plus ln of t. Y is equal to t squared plus 2. And the point that they're giving us is 3, 3. All right, so we want to find an equation to this thing, correct? And so what do we need to do? Since they want us to do it in two forms without eliminating and with eliminating the parameter, which one would you want to do first? Which one? With eliminating? Sure, let's do that one first then. So if we do with eliminating, the equation that we're given is x is equal to 3 plus ln of t, right? So we can go x minus 3 is equal to ln of t, right? And that's going to become e to the x minus 3 is equal to t, right?
Right.
Okay. So then from here, what that's going to end up giving us is, let's see if we can get this. Our y, right? Because we have the y equation over here, right? Now we know what t is, so we can go y is equal to e to the x minus 3 squared plus 2. Okay?
Yes.
So that is e to the 2x minus 6 plus 2. And what do we want to do? We're trying to find the slope so we can get our equation, right? We've got the point, now we got to get the equation. So now we're going to go, all right, so dy dx is going to be what?
Is it 2 times e to the 2x minus 6?
All right, you said it's 2e to the 2x minus 6. Wonderful, that's it. Now, since we're looking for the slope, we're looking at the slope at a specific point, right? So we're looking for it when x is 3 because we have this piece here, right? Does that make sense?
Yes.
Okay, so we should get 2e to the 0, so our slope should be 2. Right?
Right.
Okay, so then from there, if we go to point slope form, we're going to go y minus 3 is equal to 2 times x minus 3. But WebAssign's picky, so we're going to have to solve that out for slope-intercept form, slope-intercept form. So we should get y is equal to 2x minus 6 plus 3 is going to be a minus 3. And there's our equation. That is our tangent line. We okay?
Yep.
Okay, so that was with elimination. Let's do it without elimination. All right, so we have two equations. X is equal to 3 plus ln of t, and y was it t squared plus 2? Yeah. And so we can get the derivative of each, right? So what's the derivative of dx dt?
Just 1 over t.
Cool, 1 over t. What is dy dt?
2t.
2t. Okay, now we need to remember that dy dx is equal to dy dt over dx dt. So that's going to be 2t over 1 over t, right? Which will give us 2t squared. We good?
Yes.
Okay, so now in order to be able to find our slope of this thing, what do we need to do? I need to find out what my t value is, correct?
Correct.
Yes.
Okay,
Correct.
so if x is 3 plus ln of t, we're going to try to solve for t. So we see that 0 is equal to ln of t. E to the 0 is t, so t is equal to 1. Agreed?
Agreed.
So then this evaluated at t equals 1 gives me a slope of 2. How convenient. That's exactly what we had before. And we go through the same process that we did, right? Point slope to slope intercept form. Agreed?
Agreed.
All right. So I showed you with both methods, by eliminating, right, substituting in each, or by remembering that dx or dy dx is the same is equal to dx or dy dt over dx dt, and then being able to find the slope that way. Pretty straightforward, right?
Yep. Pretty straightforward.
All right. All right, let's go on to the next one. Number 3. All right, so here we go. So I'm going to say find dy dx Do you know what that second notation is right there?
Second derivative.
Second derivative, right? I don't know if some of your teachers did or did not cover that, so just trying to leave that so that you would have it. So here's my x in parametric. Here is my y in parametric. So let's find dy dx.
Two t plus 5.
Okay, so we're going to get 2t plus 5 over 2t, right? And we could, I guess we could clean that up if you want, but I don't really care. Does everyone agree with me that that is dy dx?
Yes.
Okay. How about to find the second derivative? Do you remember the formula? Or should I write it down for you?
The quotient rule?
For this guy, it's a little bit different. Remember, in parametrics, it's going to be dy, or it's d dt of dy dx over dx dt. So what it's saying is take the derivative with respect to t of what we got in the first derivative over the derivative of the denominator. So the derivative of the denominator is 2t. Okay? And so what does that give me? What's the derivative of this? Close. A negative. It's a negative 5 over t squared over 2t. Right? It's negative because the 5 over t, if you bring it up, becomes 5 times t to the negative 1, and then when we take the derivative, the negative goes in front, correct? So then that's going to give me a negative 5 over 2t cubed. Oops. Is that right? Hold on. Let me make sure. Actually, let me work it out. Want to make sure we're all good. So I'm going to get 5 to the negative 1 over 2t. So oh, I'm silly. I left out the 2. So here, let me clean it up for you. So I'm going to get a negative 5 over 2t squared over 2t. Right? Sorry, I copied it wrong. See how I left out the 2? And so that's going to give me a negative 5 over 4t to the third. Terrible. Any questions on that? We're okay? Okay, then the next piece on this one's going to ask, when is it concave? When is it concave up? So when is it concave up?
Whenever the slope is positive.
Correct. So whenever the slope is positive. So when is the slope positive for this parametric?
Would be equal to slope to 0.
So looking at what's going to help us to dictate concavity? Is it the first or second derivative?
Second derivative.
So it's a second derivative. So then we're going to have to look at the second derivative, and the second derivative tells us what? Looking at the second derivative there, I boxed it, right? Oh, I should box the first derivative so you guys have that. When is this positive?
T has to be negative for it to be positive.
Correct. So it's the interval is going to be from negative infinity to 0. That's when it's concave up. We okay with that? All right. Next. So x is e to the t, y is e to the negative 3t, and I want you to find my Cartesian coordinate by doing the elimination of the parameter, okay? call it a CE equation of the curve. All right, do you guys want to tell me what to do? Okay, I mean, we could do that. We could do that. Is there something simpler maybe that you guys could see? You guys need some help? See, this is funny. It's not even calculus. It's like, do we see a pattern, right? What do we see in relationship to this with this? That's right. So can I take the y, and go e to the t to the negative 3? Right? So then what's that going to be? Isn't y then x to the negative 3? Or y is 1 over x cubed? But we have a restriction, right? What do we have our x's have to be? There is a restriction on the x's. The x's have to be greater than 0. Do you guys understand why it's greater than 0?
No.
Okay. X equals e to the t is, if x is equal, I'll write it down. Since x is equal to e to the t, when is e to the t ever negative? Never. So that means x isn't going to be 0 and it isn't going to be negative. So the restriction on our x means it has to be greater than or equal, greater than 0. Does that make sense?
Yeah.
Okay. And then so to graph this thing, then we need to graph it. That's fair enough. It's easy. 1 over x cubed is simply going to look like this, and the direction it's going from is from 0 to infinity, right? So the direction it's going to is that way. Any questions on this one? No? You guys get it? All right, very well. All right, very well. Let's go on. Let's do the next one. And the next one says, it's a bunch of writing. So it's saying, find the point on the curve where the tangent is horizontal or vertical. And we did this, right? We did this in class in a lecture. So here is our problem. X is equal to t cubed minus, that should be a t, minus 3t, and y is equal to t squared minus 3. All right. So to find the horizontal, what do we need? We need the derivative, right? And the derivative needs to be equal to what to be horizontal?
0.
0. Good. So what is the derivative in parametrics?
dy over dx.
Cool. So dy over dx. So that tells me that I'm going to get dy dt over dx dt, correct? So dy dt, is that going to be 2t?
Yeah.
Over 3t squared minus 3?
Yes.
Right? And then this is supposed to be horizontal, so it's gonna be r0, right? What this thing being equal to 0 to get a horizontal. So I'm again just writing it down so you guys have that. That's so it's a horizontal. And so what's gonna make that thing 0? What makes a fractional thing 0?
Is the numerator 0?
It's the numerator. So then the numerator being set equal to 0 tells us that this thing's going to have a 0 where? What t value? This is the numerator, right?
Yeah.
So then what's t?
At t equals 0.
T equals 0. So when t equals 0 is what we're going to have, right? But they want a point. So if they want a point, they're going to want it in the x and y. So what's my x going to be?
0.
Perfect. What's my y going to be?
-3.
Perfect. Does everyone see where Andrew got 0 and -3? Is there anyone that doesn't see it? Please. We're okay? It's a lot quiet.
Yeah, you just plugged it in, right?
Yeah, just plugged it in to here and here once we found t. All right, now to find the vertical, what do we need to do?
Set the denominator equal to 0.
Cool, so when is the denominator going to be equal to 0?
When it equals to 1.
And?
-1.
Perfect. So my t has to be plus or minus 1, right? So then I'm going to have 2 points in this one. So one of them's going to occur where? And where's the other one going to occur? Here we'll say this one's when t equals 1, positive 1. That's going to look like -2 and -2. And this one's going to be at 2, -2. Agreed?
Agreed.
Are the rest of you guys here?
Yeah, agreed.
All right, just making sure, because I'm like, I feel like your guys' energy's been zapped. Is there too much going on in the world?
There's more than that,
What's that, Aaron? Couldn't really hear him.
He said he's just stuck at home all day.
Oh yeah, we're all living that dream.
But I think chapter 11 keeps me busy enough.
It's an interesting it is an interesting chapter, isn't it?
Yes.
You'll be okay, and that's why I want to go over. That's why I want to go over problems with you guys in 11, as opposed to just lecturing on it, because you can get lost with all like the theory and tests. Wait till you get all the ratio tests and comparison tests and root tests. It's going to be crazy. So at least there's a vaccine now. So maybe we'll go back to school soon. Hopefully. Who knows? Maybe not. All right. Let's go on to the next set. And here's this problem. So this is number 6, I believe, correct? All right. So find the points on the given curve where the tangent line is horizontal, so it's kind of the same thing, or vertical. And we're assuming we're going to be in a 0 to 2 pi thing, okay? So we're given r is equal to 1 minus sine theta. So let's go get our horizontal first. Okay, so to get the horizontal in a problem like this, what do we need to do? And again, it was from 0 to 2 pi, just so you know, included. How do I get the horizontal when I'm in polar coordinates? What's that? I mean, we could graph it, but that's not really needed. What can we do to be able to solve this problem?
You get the derivative first.
Oh, okay. So we could do the derivative if you'd like. One of the things that might be beneficial is to remember and see if we can put this in a form that's useful for us. So, do you remember that x is equal to r cosine theta and y is equal to r sine theta? Right?
Right.
So would it be beneficial if we turned it into x's and y's so we could more cleanly see what's going to happen? Because in the horizontal, what are we interested in? Aren't we interested in the numerator?
Yes.
Okay, so let's look at this. So if I go, x then is going to be 1 minus sine theta cosine theta, right? And y is going to be 1 minus sine theta sine theta. You agree with that, correct?
Yes.
Okay, so then when we look for the derivative for the horizontal, we're going to be looking at dy d theta, correct?
Right.
Okay, so what can we do? What's the derivative of dy d theta? We're looking at this one, right? So negative cosine theta times sine theta, right? Plus 1 minus sine theta cosine theta. Do we agree? Okay.
Agreed.
So that gives me a negative cosine theta sine theta plus cosine theta minus sine theta cosine theta, which gives me cosine theta minus 2 cosine theta sine theta, which is the same as cosine theta 1 minus 2 sine theta. Agreed?
Agreed.
And now we're trying to find the horizontal, so we need to set each product equal to 0, right? So cosine theta is equal to 0, 1 minus 2 sine theta is equal to 0. So when is cosine equal to 0 in the pi world?
At pi over 2 and 3 pi over 2. Wait, yeah. Cosine?
Cosine?
Yeah. At pi over 2 and 3 pi over 2, correct?
Okay, so let's look at a circle real quick. So for cosine to be 0, right? We need to be up here and here, right?
Yeah.
Okay, so that means we're gonna get
Pi over 2.
pi over 2 and 3 pi over 2. And since we're only in the unit, we're only from 0 to 2 pi, that's what we're gonna get, right?
Yeah.
And then over here, I'm gonna get sine theta is equal to 1/2. So when does that happen?
Pi over 6 and 11 pi over 6.
So it's a positive 1/2, so it's gonna be up here
Oh, yeah.
and up here. So shouldn't it be pi over 6 and 5 pi over 6?
Yeah.
5 pi over 6? Yes, 5 pi over 6. Okay. So then the values that we have are these, right? Okay. So now we got to put them in the points. So where do these points occur? So remember, it's we want r comma theta, right? So the values that we're going to get are 1/2 pi over 6. Agreed?
Agreed.
Comma 1/2 5 pi over 6 and 2 3 pi over 2. Are we good?
Yes.
Does everyone understand where I got those values?
You saw the last one?
Oh, how I got this one right here? Hold on. This one?
Yeah.
Okay, so you get the angles of 3 pi over 2, right?
Yeah.
So that's the theta. And then we need to find the r. And to get the r, we need to go back up to the original.
Okay.
Does that make sense? So that's how we're getting the radiuses from the original. Cool? All right, let's go after the vertical. So for the vertical, how do we get the vertical?
Taking the x d theta.
So we're going to look at dx d theta, right? And so dx d theta is going to be what? It's over here. So to me, I think it looks like negative cosine theta times cosine theta plus, what was it, 1 minus sine theta. Derivative of cosine theta is negative sine theta. Agreed?
Agreed.
Okay, so let's clean this up. So I'm going to get a negative cosine squared theta minus sine theta plus sine squared theta. Well, that doesn't look very helpful, does it? So let's manipulate it. So I'm going to go negative 1 minus sine squared theta minus sine theta plus sine squared theta. That's going to give me a negative 1 plus sine squared theta minus sine theta plus sine squared theta, which will yield 2 sine squared theta minus sine theta minus 1. And I think that's factorable. Right? We need minus and plus. And then this is going to be set equal to 0 again, correct?
Yes. Correct.
Oops. Jumping the gun. So we're going to get sine theta is equal to a negative 1/2 and sine theta is equal to 1. So when is sine theta equal to a negative 1/2? And 11 pi over 6, correct?
Yeah.
When is sine equal to 1?
Pi over 2 and 3 pi over 2.
Just pi over 2.
Oh, yeah, that's negative.
Now, no one asked me earlier up here why I neglected pi over 2. The reason I neglected it is because we see that it becomes a vertical issue. Does that make sense? And I knew that, but if you didn't know that, you would have plugged in and gotten a number, and then you would have had to double check. So you always want to make sure to double check. Does that make sense?
Yes.
Okay. And the way you can double check if it falls in the top and the bottom, really the reality is the denominator is going to always trump the numerator. But you could have also taken the limit as you approach pi over 2 of the derivative and seen that it would have gone to infinity or negative infinity, right? Make sense?
Makes sense.
Okay, so, all our values are going to be 3 over 2 and 7 pi over 6. 3 over 2, 11 pi over 6. And our last one's going to be 0 and pi over 2. And again, this is in r and theta systems where we have our vertical tangents. Seem doable?
Yes.
Okay. All right, next problem. What is this? This was number 6, so number 7. Oops. So find the slope of the tangent line. Okay? And I'm going to give you r is equal to 8 minus sine theta. And theta is pi over 3. So why don't you guys try that, and then I'll do it. See if you can do it. Excuse me. Have you guys picked up the trick on what to do?
We start by doing the x equals r cosine theta. What? Okay.
That's the trick. Do you guys agree with what I've got? I'm just going to leave it that way. 8 cosine theta is 2 cosine theta sin theta over. Where is this being evaluated at?
Pi over 3.
Perfect. Perfect. So my theta is pi over 3. So 8, I think that's a half, minus pi over 3 for... Oh, that's a rule, right? Isn't 2 sine squared cosine, 2 sine squared cosine 1/2 sine 2 theta? Or is it, no, it's just sine 2 theta, right? Because it's got the 2 already. This, can't I rewrite that as sine 2 theta?
Yeah, you can.
So then that would be at pi over 3, that'd be 2 pi over 3, sine of 2 pi over 3. 2 pi over 3, is that a half? No, it's rad 3 over 2. Okay. Oh. And isn't this one cosine of 2 theta? Right? Do you guys agree with that?
Yes.
Alright, so what the heck does that become for my slope? 4 minus rad 3 over 2 over negative 4 rad 3 plus a half. If I multiply everything by 2, I'll get 8 minus rad 3 over negative 8 rad 3 plus 1. Plus 1? Yeah. And that's my slope. Real quick, just remember that the big key trick to this whole problem is remembering this. Okay? Let's get more funky. Let's find the area of the region enclosed by one loop of the curve. So that means this thing's going to be a little bit more funky, right? And here is the equation. It's R is equal to 8 sine 7 theta. So we have to be able to graph this thing. So how do we graph this thing? You can do charts, or you could use your calculator. Okay? Can you guys graph this?
On the calculator. Well, I could do it with the chart, but it just takes longer.
Yeah, it takes forever. But if you can do it with your calculator, then it's a big thing. So I'm just going to take for granted that you guys can graph it. And so this thing's going to look something like this for one closed loop. And this is reaching all the way to 8. Okay? Oh, excuse me. Dying. Okay. So here's what we're going to do. We're going to try and see if we can find some angles, because that's what we need to find, right? In order to be able to do this problem, is find angles. So it always comes back to 0. Do you guys see that? Right? There's a bunch of them. Like there's one here, there's one over here. It ends up looking like a petal everywhere, right? But the angle always comes back to the radius always comes back to 0. Does that make sense? And it comes back to 0 a lot. So what I'm going to do is I'm going to say, okay, r is 0 is going to help me get my angle. Okay? Because to get one loop, I'm going from 0 for my radius all the way around to this and then coming back to 0. Does that make sense?
Yes.
So we know that our first angle, we can see it because 0 is going to be equal to 8 sine 7 theta. We know that the first angle is going to be 0. Do you agree with me? Okay. So now we got to find the next one. And so what's going to end up happening is I'm going to go, all right, 0 is equal to sine 7 theta. So sine inverse is going to be equal to 7 theta, right?
Yes.
Or another way to do it to even make our lives easier, we know at this point that it's just going to be products of what's going to make this angle be 0. Or I'm sorry, sine of that angle be 0. It's going to occur at pi, and it's going to occur at 0 and at pi, right? And multiples of pi. You agree?
Yeah.
So then that tells me that 7 theta is going to be some pi times n. Right? And n can be 0, 1, 2, 3, 4, right?
Right.
Okay. So then the first one we got, obviously we said was 0. The next one would be when our n is 1, right? Because it's the first time we come back. So it's 0 here, and then the first time we come back is right here. So that would be, our n would be 1. Agree?
Agreed.
Okay. So to make it so that we want the angle, because that's what the hell we want, it's going to be pi over 7 times n. And we said the first one was at 0 and the second one was at 1. So the angles that we're going to have for our area for this closed loop is going to go from 0 to pi over 7. Right?
Yes.
Okay.
Yes.
When we're doing these problems, what was the equation for area? It was the integral of what?
1/2 r squared times d theta.
D theta. So we have our r, right? So we're going to go 1/2. It's going to be 8 sine 7 theta squared d theta. Right? So we can do that. What the heck is that? 64. Half of 64 is 32. We're going to have sine squared 7 theta from 0 to pi over 7 d theta. Agreed?
Yes.
Okay.
Yes.
Sine squared. You should have bells ringing, right? What does that do? How do we integrate sine squared?
1/2.
That's right. It's going to be power reduction, correct?
Yeah. Cosine.
Yes. So I'll go 32
Cosine.
pi over 7, 1/2, 1 minus cosine of 14 theta. Agree? All right, so we can do that. That's going to be 16 integral from 0 to pi over 7 of, oops, I already took care of that, of d theta minus 16 integral of cosine of 14 theta d theta so that's going to give us 16 theta minus, here I'll do it this way, it's actually cleaner, 1 over 14 sine of 14 theta, agree? Going from 0 to pi over 7. Do we all agree with that?
Yes.
Okay. So let's just do the inside piece first. So I'm going to get pi over 7 minus 114. 2 pi is going to be 0, right? Minus 0. Sine of 0 is 0. Oh, that's cool. So that's a big fat 0. So I'm going to get 16 pi over 7 as my area. We okay? We all right?
Yeah.
This should be a helpful test, right? All right, what number are we on? Number 9. Okay. All right, number 9. Find the area of the region. The cat outside. It's just staring at me. That lies inside, I left out, inside the first curve and outside this second curve. So there's going to be 2 curves to this thing. So the first curve is r is 19 sine theta, and the other is r is 10 minus sine theta. And we really don't even need to graph this, right? Because if we know what's outside inside, it shouldn't be too bad, right? So what's going to be outside? Which one of these 2 equations is outside? Want me to give you a hint?
Yes.
Okay. Check this out. So, if I put in pi over 2, what's this going to be?
0.
Pi over 2?
Oh, pi over 2, my bad. 19.
What's this one going to be?
-10.
Negative 10. Isn't that going to be 9?
9.
9. So if this is 19 and this is 9, which is going to be on top of the other? This one's on top, this one's on the bottom.
19 too.
Right? So in order to find the area between the two, it's going to be this minus this. Agreed?
Agreed.
Okay. But because they're both polar, we need to remember its area is 1/2 r squared. So we have to take the area of each and subtract. So my integral is going to be 1/2 19 sine theta squared minus 1/2 10 minus sine theta squared d theta. Are we in agreement there?
Yes.
Okay. We can find the parameters by setting them equal to each other. So sine theta, or 19 sine theta is equal to 10 minus sine theta. So we're going to get 20 sine theta is equal to 10. So sine theta is equal to 1/2. When does that happen? Pi over 6 and
5 pi over 6.
5 pi over 6, right? Now, one of the things that's cool about this thing, though, is we see, or we should know, that there's going to be symmetry to this, right? Because the curves are, they're both ellipses, actually. So there's symmetry that we can do, and we can go from pi over 6 to pi over 2. Okay? So that's what I'm going to do. So I'm going to go from pi over 6 to pi over 2, but I'm going to double it because I'm doing symmetry. Okay? So I'm going to get 1/2 19 sine squared, this squared minus 10 minus sine theta squared. And now we have to expand this thing. So, all right, let's see. The 1/2 and the 2 will cancel. So I go from pi over 6 to pi over 2. 19 squared. Is that 461? 361. Because 20 is 400. Right?
Right.
Okay. Minus, that's going to be 100 plus 20 sine theta minus sine squared theta. Am I right? I think that's right, right? Check me, my friends, please.
Yes, that's right.
Yeah.
Okay, cool. And then 360 sine squared theta plus 20 sine theta minus 100 I can pull a 10 out of everything, right? I want to deal with smaller numbers. So 36 sine squared theta plus 2 sine theta minus...
Instead of put a 20.
Oh, I could pull out a 20. Shoot.
Yeah.
Why don't we do that? So, is that 18?
Yes.
Yeah, 18, 1, and 5. All right. So we could break it up and do individual. Do you want to do individual? We can. It's fine. I'll just do it this way. Boom. That's going to become 9, 1 minus cosine 2 theta. Agreed?
Agreed.
Okay. Let's do this. So I'm going to get theta minus 1/2 sine 2 theta. All of that times 9. Agreed?
Agreed.
And then it's just plugging in. Oh, Lord. Does someone want to plug it in and tell me what the answer is? Oh, I didn't. All right, dude. 9, what is that? Pi over 2 minus, that's going to be, that's 0. And then minus pi over 6 plus 1/2. Pi over 3 is a half, right? No, pi over 3 is radical 3 over 2. Minus 0 plus cosine of pi over 6. Is that 1/2? Yeah. Minus 5 pi over
I think it's 3 over 2.
Cosine of pi over 6?
Yes.
Yeah, it is right. 3 over 2, you're right. I was thinking pi over 3. 5 pi over 2 plus 5 pi over 6. All right, so 29 pi over 2 minus pi over 6 plus rad 3 over 4 plus rad 3 over 2 minus 5 pi over 2. All right. We're almost there. 2 pi 3 pi over 3 pi over 4. 3 pi. All right, let's see if we can clean this up. All right, let's put the pi's together. 5 minus 4 is 4 pi. That's 2 pi. That's plus 4 pi over 6, right? Which is 2 pi over 3. Plus, that's going to be 3 rad 3 over 4. Do you guys agree with me? Six, 7, 8 pi over 3 plus 3 rad 3 over 4 times 20. What the heck is that? 160 pi over 3 plus 5, 15 rad 3 over 15 rad 3. I think we did something wrong. We must have plugged in some values wrong. My integration was right though, right?
Section, isn't it supposed to be 9 pi over 2 minus 9 pi over 6?
Are you saying right here?
One down.
That's supposed to be 9 pi over... Oh, I didn't distribute the... Wait. No, I think this one correlates with this one. Because at 9 pi over 2, right? Minus 9 pi over 2. Oh, okay. Yep, I think you're right. I didn't multiply here. Very good. So then this should be 9 pi. And then this one, that's 9 pi over 6. And then this one should be... This one here should also be multiplied by 9, correct? So this should have a 9. Agreed?
Yes.
Alright, so then let's fix this piece here. Oh, it's always being so meticulous. Okay. So let's see if we can clean this up. 9 pi minus 5 pi is going to be 4 pi over 2. So that's still 2 pi. But now we're going to get a negative 4 pi over 6. Is that right? Plus 2, so that's going to be 11 rad 3 over 4. Is that correct? So what the heck? 6. Oh, let's make that 2/3. So 6, so 4 pi over 3. Plus 11 rad 3 over 4 multiplied by 20. That's going to be 80 pi over 3. 55 rad 3. That's it. Yep, I distributed. Isn't that funny that it was an algebra, like arithmetic? It wasn't even something crazy hard. It was just arithmetic. Okay, let's do one more and then we'll call it, okay? And this is kind of what your exam is going to look like, so study these problems, okay? This is number 10, right? Yes?
Yeah.
All right. So which one do I want to do? Which one do I want to do? All right, let's do this one. All right, so it's going to go from polar to... Oh, no. We're going to go from Cartesian to polar. Okay? All right. And they're giving us x squared plus y squared is equal to 10cx. So what can we do with this problem? What do you guys think? Any thoughts? Right? So isn't that going to be r squared is equal to 10c r cosine theta?
Yes.
So then right? And just in case you don't see that step in between, isn't that r cosine squared theta plus r squared sine squared theta is equal to 10c r cosine theta. So then I'm going to get r squared cosine squared theta plus sine squared theta is equal to 10c r cosine theta, which is r squared times 1. And there we go. That's all the steps in between, just in case you didn't see it. Does that help?
Yes. Thank you.
All right. Okay, here, let me stop recording, and then I'll answer any questions you guys might have for me.